So in the previous two lessons, we looked at how to solve inequalities using any of the four main major operations. Here we're going to look into, okay, we're going to get a little bit more complex. The same rules apply though, same rules. So remember, if you multiply or divide by a negative, we got to flip the inequality sign. And then all the strategies you learned back in chapter 2 for solving equations, we can use in chapter 3 as well. So there's nothing new here. So let's dive right in. We've got 6 problems we're going to look at here. And we're going to then do a closer, and then that's it for this lesson video. So diving right in here, we've got negative 12 is greater than or equal to 3x plus 6. I got two things happening to x. I'm multiplying by 3 and I'm adding 6. I've got to get this down to x. So remember, the first thing you want to get rid of here, you want to combine your like terms. Like terms here would be negative 12 and 6. So I've got to get the 6 off of the right side. The opposite of adding 6 is subtracting 6. Negative 12 minus 6 is negative 18. Is greater than or equal to 3x. To solve this, divide by 3. 3 divided by 3 is just x. Divide this side by 3, negative 18. Oh, divide by 3, not negative 3. Negative 18 divided by 3 is negative 6. Now, that's important that I caught that mistake and I didn't put a negative sign there because I'm dividing by a positive. Inequality sign stays put. So we're going to put the dot at negative 6. It's going to be a closed dot because this is greater than or equal to. We're including negative 6. It is inclusive. So include that negative 6. And let's try a couple test points. Negative 7 on this side, negative 5 on this side. Well, if I take negative 7 and plug it in for x, is negative 6 greater than negative 7? Yes, it is. But take negative 5. Is negative 6 greater than negative 5? No, it's not. So my arrow is going to go to the left toward negative 7 because negative 7 is one of the solutions and everything less than negative 6 are the solutions there. Okay, let's move on to number 2. On number 2, again, these are just more complex problems. A lot of people, what they'll want to do is try to get rid of this 1 first. We can't do that because this isn't 1 and this isn't 2. It's not 1 and it's not 2 because look, it's all in the numerator of this fraction here, which a fraction we can read this as division. So this isn't 1 because it's being divided by 3. Same thing with this. It's like this is locked inside parentheses. So we got to get rid of this 3 first before I can get at the stuff in the numerator, before I can get rid of the 1 and get rid of the 3. So, or get rid of the 2, sorry. So we're going to multiply both sides by 3. Notice when we multiply by 3, that's like 3 over 1. So this cancels out. Okay, so I have 1 minus 2n on this side. I multiplied by a positive, so this stays the same, okay? On here, a lot of people will do plus 1 because they see that minus sign and think, oh, the opposite of subtracting is adding. The problem with that is, what's 1 plus 1? Well, it's not 0. To get this 1 to go away, I have to do 1 minus 1. That minus sign right here is for the 2n, not for the 1. You can think of this as adding negative 2n, right? So when I do that, I got negative 2n over here. And then on this side, I also want to do minus 1, so I get 21 minus 1 is 20. I haven't divided by a negative yet, so I'm going to keep this there. But notice here, to solve this, I have to divide by negative 2. Negative 2 divided by negative 2 is 1. 20 divided by negative 2 is negative 10. And I divided by a negative, so flip the inequality sign. So n is greater than or equal to negative 10. So graphing this, we're going to have a closed dot. And n is everything greater than negative 10. So that would be negative 9 on up toward the positives. Okay, so there's the first 2. Let's keep going. We'll go to number 3. Number 3 it looks complicated, but if you think about it, we've got a little bit of math we can do on this side right here. This is 2, if you read it out loud, it's 2 minus negative 10 is greater than negative 4t. Well, I can do 2 minus negative 10. 2 minus negative 10, we're subtracting a negative. That's the same thing as adding a positive. So that becomes 2 plus 10, which is 12. 12 is greater than negative 4t. Now it's just solving. I'm going to divide by negative 4. And our special rule applies here because we divided by a negative. Positive divided by a negative is a negative. I'm going to flip the inequality sign. On this side, negative 4 divided by negative 4 is just 1t. So negative 3 is less than t. So got to be careful because our variable is on the right side here. We have an open dot at negative 3 because we're not including that value. It's just less than, not less than or equal to. Now let's try some test points. Let's take negative 2 and plug it in. If I take negative 2 and plug it in for t, is negative 3 less than negative 2? No, yes, negative 3 is less than negative 2. That's correct. What about negative 4? Is negative 3 less than negative 4 if I plug negative 4 in for t? That's false. So negative 3 is less than negative 2, therefore I've got my solutions have to go toward negative 2 and beyond. Moving right along. Okay, on this one, we're going to go back to chapter 1. Remember the lesson on simplifying expressions. I cannot do 2 minus x here. I can't subtract those because they're not like terms. That's not 2x's, that's just 2. So what I have to do is I have to distribute this negative 4. I have negative 4 of these 2 minus x's. So, let's do blue. What that looks like is we multiply everything inside by negative 4. Negative 4 times 2 is negative 8. And then if I multiply, you can think of this as minus x, or you can think of that as adding negative x. Well, a negative times a negative is plus 4x, less than or equal to 8. Okay, I got to get rid of this 8. I got to make it equal 0. So that's, I can either do the opposite of adding here is subtracting negative 8, or subtracting negative 8 is adding 8. So I have 4x is less than or equal to 16. Divide by 4, divide by 4, x is less than or equal to 4. And now we're going to plot that. We need a closed dot because it's less than or equal to, so we're including 4. 5 this way, 3 that way. X is less than 4, so that would go toward 3 and all the numbers that are less than 4. Okay, let's go on to number 5. So number 5, you could solve this by subtracting a half, getting common denominators, all that stuff. But sometimes it's just easier to work without fractions. So here's where we can use that strategy of clearing the denominator. So think about what's the least common multiple of 2 and 3, the denominators here, here, and here. Because really, remember the denominator, another way of thinking about that is division by 3 or division by 2. So if I can think of a number that both 3 and 2 go into, and if I can multiply all 3 terms by that number, that'll get rid of my denominator here. So if you think about the least common multiple of 2 and 3, that's 6. If I multiply 2/3 by 6 over 1, watch what happens. Well, 3 goes into 6 twice, and then 2 times 2f would be 4f. Bring the plus sign down from right here, right? And now I also have to multiply this half times 6 over 1. This 2 goes into 6 3 times, 2 becomes 1, and then you have 1 times 3 is 3. Greater than, I'm multiplying by 6. Now if I multiplied by negative 6, I would have to flip this inequality sign here, okay? But as it is, I multiplied by 6. I didn't multiply by a negative. All right, so let's multiply this by 6 over 1 as well. This becomes a 1, this becomes a 2. 1 times 2 is 2. Okay. Now, to solve. Now I've got a new equation, or inequality. And notice this inequality, by the way, I need to point this out. This inequality and this inequality are exactly the same because I multiplied the whole thing by 6. If I multiply everything by 6, then it's the same thing still. So we need to start by subtracting 3 from both sides. I get 4f is greater than negative 1. Divide both sides by 4. And a lot of people pull their calculator out. You don't need to. If it's negative 1 divided by 4, just leave it as a fraction. So f, I divided by a positive, so I don't have to flip the inequality sign, is greater than negative 1/4. Graphing it on the number line. Negative 1/4 is in between negative 1 and 0. It's also in between negative 1/2 and 0. So I could just do a number line by fourths, just to be a little bit different here. This is an open dot because it's not or equal to, and f is greater than negative 1/4. Well, which is greater than negative 1/4? Negative 1/2 or 0? 0 is greater. So we go to the right. Okay. Let's take a look at this word problem here. The average of Ethan's 2 test scores must be at least 90 to make an A. Did you hear the inequality there? The inequality is at least, right there. I'm going to go to the highlighter. At least 90. Okay? Could it be less than 90? No, it cannot. So it has to be more than 90. So let's write this down. Average at least 90. Okay? Well, at least would mean the average, right here, is more than 90. Could it be equal to 90? Yeah, if it's 90, it's at least 90. So it's greater than or equal to. How do we find the average? Well, this is 2 test scores, right? The average is adding up all the values and dividing by the number of values. Remember that from data analysis unit last year. So that would be the first test score plus the second, since there's only 2 tests. First plus the second divided by 2. Let's define a variable here. What don't we know? Well, the question is what grades he got a, well, let's highlight this. I'm getting ahead of myself. He got a 95 on his first test. Okay, so his first test was a 95. Filling in information as we go here. First test was a 95. What grades can Ethan get on his second test? There's our variable. Okay, so grades, so let's do G is grades on second test. Grade singular probably makes more sense grammatically there. So grade on the second test. So this would be 95 plus G. And now we just have an equation we need to solve. I'm sorry, an inequality. All right, so to solve this, we got to get rid of that denominator just like we did back in number 2. Got to get rid of that 2 before we can attack the 95. If you can't subtract 95 yet, I got to multiply by 2. So remember, if I multiply by 2 there, those cancel. I'm left with 95 plus G on the left side. Multiply this side by 2, and I get 180. So think about what that would mean. 95 is his first test score, G is his second test score. The sum of the test scores must be greater than or equal to 180. Subtract 95, and you get G is greater than or equal to 85. So in a sentence, let's go ahead and type out a sentence here. Write this down. I just need to interpret this. Ethan must score 85 or higher to get at least an average of 90. Okay, so make sure you type that out as well, just so you have an interpretation of your answer. On word problems, I want a sentence just to kind of show that you understand what the solutions are. Okay, quick closer. Look at these solutions without solving them. tell whether there would be one solution, or there would be a positive solution, a negative solution, a solution of 0, or no solutions, or infinitely many solutions. Okay, so pause the video and then hit play when you're ready. Okay, looking at number 1. Number 1 says y is greater than y plus 1. Well, if you think about it, can y ever be greater than itself plus 1? Like, we're taking that same number and we're adding 1 to it. So this value can never be greater than this value. So this would be no solution, because it's not possible for that statement to be true. 2x plus 7 is less than 7. Well, think about solving this. Just, you don't actually solve it, but I would have to subtract 7, and 7 minus 7 is 0. 2x would be less than 0. That's because you're going to get a solution of 0 when you solve this. 3b is less than or equal to 3b. Well, that is a true statement. It's not 3b isn't less than 3b, but think about it. Solutions are anything I could plug in for b. What numbers could I plug in for b that would make this true? Well, anything I plug in on the left side, I'm going to plug the same number on the right side, and they're equal statements on either side. So therefore, this is infinitely many. And then on this one, 5c is greater than negative 5c. Okay, so is this going to be a positive solution, negative solution, 0 solution, no solution, or infinitely many? For this, you kind of got to think about cases. If c is negative, so let's say c was negative 2, I'd be doing 5 times negative 2, I'd get negative 10 on the left. On the right, I'd have negative 5 times negative 2. I'd have positive 10. Well, if c is negative, then there are no negative solutions, right? What about if c is 0? Could I get a 0 solution? Well, if c is 0, well, then this 5 times 0 is 0, negative 5 times 0 is 0, and we would get 0 is greater than 0. Well, that's not true either. So right now, we can't have negative solutions, we can't have positive solutions. We're starting to think, well, can we have any solutions? Let's think about if c is positive. Well, if c is positive, over here, I'm doing a positive times a positive, and over here, I'm doing a negative times a positive. So on this side, positive times a positive is always positive. And on this side, clean up a little bit over here. Negative times a negative is always a negative. And a positive is always greater than a negative. So if c is positive, we get solutions, right? So this would have to be positive, a positive solution. Okay? So just something a little closer there to keep you thinking, keep you engaged with thinking about what solutions look like, not just getting in a habit of solving these, but making sure your answers make sense. Go ahead and try the homework. When you're done with that, move on to the next lesson.